Hello children, welcome to my channel. Today I am going to explain you about what are thermal decomposition reaction. Before going to the topic, I would like to explain you about what are decomposition reaction. See, from the word decomposition, we have a term decompose. That means something is decomposing, right? What do you mean by decompose? Decompose means breaks down to simpler products. What something is breaking down into simpler products, that is called decompose. And here what reaction is this? This is decomposition reaction. So what is breaking down? A single reactant. A single reactant breaks down into many simpler products. This reaction is called decomposition reaction. So decomposition reaction is the process by which a single reactant decomposes or breaks down into two or more simpler products. Let's see the example. Calcium hydroxide. This is a single reactant. It breaks down to calcium oxide plus water. See this, a single reactant breaks down to two products. This type of reaction we call it as decomposition reaction. Just see the general equation for that. Suppose I have the reactant AB. The name of this reactant is AB. This is my reactant. See, this reactant converts into two products. And what are the two products? My one product is A and another product is B. See, I have a single reactant AB which decomposes or breaks down into the product A and the product B. And this type of reaction in which single reactant decomposes into many simpler products is called decomposition reaction. Now, decomposition reactions happens only through the input of energy. Now, how we supply the energy? We can supply the energy through three methods. Either you heat the reactant, or you supply electricity or electric current, or you supply light. Any of the input of this energy helps in the decomposition reaction. If we supply heat to the reaction, then we call this decomposition as thermal decomposition. That is decomposition reaction carried out with the supply of heat energy. So here comes our topic, thermal decomposition reaction. So let us define thermal decomposition reaction. It is the reaction in which a single reactant breaks down to two or more products with the help of heat energy. When the heat is applied, we call it as a thermal decomposition reaction. Now you understood what is thermal decomposition reaction? The reaction in which a single reactant breaks down to two or more products with the help of heat energy. So our today's topic is thermal decomposition reactions. Let us see the examples for thermal decomposition reaction. Now example number 1. Example 1. Here FeSO4. FeSO4 is ferrous sulfate, and I am heating ferrous sulfate. For heat, either you write heat over the arrow or you put a small triangle like this. This triangle indicates it is heating. Clear? So either you put triangle or you write heat above the arrow. Now, when we heat the ferrous sulfate, we will get Fe2O3 plus SO2 plus SO3. Again, balance the equation. 2Fe2 SO4. When I heat, I'll get, this is ferric oxide. Ferric oxide plus SO2 and SO3. This reaction, there is a single reactant, and what is a single reactant? Ferrous sulfate, and we supplied heat and it decomposes into ferric oxide plus sulfur dioxide plus sulfur trioxide. That means 3 products we obtained, and from a single reactant, and we supplied heat energy for this reaction. So we call it as a thermal decomposition reaction. Let us watch this reaction.
We have some ferrous sulfate crystals. Take the ferrous sulfate crystals in the test tube. Heat it over the flame. Initially, the crystals decolorize as they lose the water of crystallization and turn anhydrous. The anhydrous ferrous sulfate then further breaks down into ferric oxide and a mixture of sulfur dioxide and sulfur trioxide. In fact, you will be able to detect the distinct smell of burning sulfur, but do not stay around for long since sulfur dioxide and sulfur trioxide are toxic gases. The decomposition reaction can be represented as 2FeSO4 gives Fe2O3 plus SO2 plus SO3.
Now, example number 2. Calcium carbonate, CaCO3. What is this? This is calcium carbonate. And when you heat this, now I am using only the symbol. The symbol is triangle. We will get calcium oxide plus carbon dioxide. What is a common name for calcium oxide? Quicklime. Here also see only a single reactant. When we heat it, we got 2 products. And what are the 2 products? Calcium oxide and carbon dioxide. So from a single reactant, with the supply of heat energy, it converts into 2 products, calcium oxide and carbon dioxide. So it is called thermal decomposition reaction. It is called decomposition because single product converted into 2 products, reactant converted into 2 products. It is called thermal decomposition because we are supplying heat energy for this reaction. Now let us watch this reaction also.
Many reactions are reversible, at least to some extent. For example, calcium carbonate decomposes to calcium oxide and carbon dioxide at high temperatures. At low temperatures, calcium oxide absorbs carbon dioxide to reform calcium carbonate.
Now, example number 3. When I heat lead nitrate, what is the formula for lead nitrate? PbNO3 twice. And I am heating lead nitrate. Again for heating I put the symbol triangle. I'll get the products lead oxide plus NO2 plus oxygen. Now balance the equation. 2, 2, 4. Now the equation is balanced. Now see, from a single reactant I got 3 products. So it is called decomposition reaction. Again, for this reaction I have supplied heat energy. So it is called thermal decomposition reaction. So lead nitrate, on heating we will get lead oxide plus NO2 plus oxygen, and this NO2 forms brown fumes. This NO2 forms brown fumes. Let's watch this example also. Now let us solve this question. Which of the following is a thermal decomposition reaction? Read the question properly. Which of the following is a thermal decomposition reaction? So out of these 4 options, we have to identify which one is thermal decomposition reaction. Let us see the first option. Carbon plus oxygen gives carbon dioxide. So what is the decomposition reaction? A single reactant breaks down to 2 or many products. Here, is there any single reactant? No. Here there is 2 reactants combined to form a single product. So this is not decomposition reaction. Wrong. This is not decomposition reaction. Now come to the option 2. Methane combines with oxygen and we get carbon dioxide and water. Again, there is no single reactant. 2 reactants are there which forms 2 products. So this is also not a decomposition reaction. This option is also wrong. And now come to the third option. Here, silver chloride converts to silver and chlorine. So, this is decomposition. A single reactant breaks down to 2 products. What are the products? Silver and chlorine. This is decomposition reaction. But the question asked is thermal decomposition reaction. So, check the above arrow. So, it is not heat. This is sunlight. So, this is not thermal decomposition. So this option is also wrong. And come to the last one. Ammonium chloride converts to ammonia and HCl. And see the what is written above the arrow. This triangle represents this is heat. So if heat is supplied to the reaction and the single reactant converts to 2 products, then it is called a thermal decomposition reaction. So the correct option is D. Ammonium chloride on heating will get ammonia and hydrogen chloride. I hope you understood this thermal decomposition reaction. So what we have learned today, what is decomposition reaction and what is thermal decomposition reaction. Hope you all enjoyed my video. Thank you.